So if I had a loaf of bread, a bowl of mustard, and 3 slices of ham, how many ham sandwiches can I make? Well, the answer is obviously 3. Put a minimum of 1 slice of ham per sandwich because I'm going to run out of the ham before I run out of the bowl of mustard or the loaf of bread. So a limiting reagent in chemistry is the reagent or the reactant that you run out of first. In my example, the ham was my limiting reagent. I'm going to run out of ham before I run out of those other things. So that limits how many ham sandwiches I can make. The limiting reagent determines how much product you can make in any chemical reaction. So in this example here of burning octane inside of the pistons in the engines of a car, shows a couple of examples of how some of the reactants can be limiting or not. So the optimal ratio is 10 grams of octane for every 35 grams of oxygen. If you have this ratio, the car is working optimally. If I had this ratio, 10 grams of octane for 36 grams of oxygen, now octane is limiting. I have more oxygen than octane, and I'm going to run out of octane first, and the engine's going to stall. If I had this ratio, 10 grams of octane for every 34 grams of oxygen, now oxygen is limiting. I'm going to run out of oxygen before I run out of octane, and the exhaust will be dirty and smoky. So how do you find out which chemical is the limiting reagent in your chemical reaction? Well, it's the chemical that makes the least amount of product. So you can recognize these types of problems because they're going to give you 2 amounts of chemicals. Unlike all of the other problems I've given you, I've only started you with 1 piece of information. These types of problems will start you with 2 pieces of information. So to solve these, we need to do 2 stoichiometry problems, one for each reactant you're given. The one that makes the least amount of product, that is your limiting reagent. So let's do an example here. If 10.6 grams of copper react with 3.83 grams of sulfur, how many grams of the product will be formed? So here it is, the 2 pieces of information. This is your clue that this is a limiting reagent problem. So we need to do 2 stoichiometry problems for each reagent. So we'll start with the 10.6 grams of copper first. So first step is always convert to moles. To do that, we're going to divide by the molar mass. 1 mole of copper weighs 64 grams. Our middle bracket is always our mole-mole ratio step. I have 2 moles of copper, according to my balanced chemical equation here, for every 1 mole of my product, the Cu2S. And then our last step is to convert into grams of Cu2S. In 1 mole of Cu2S, I have 2 moles of copper, which both weigh 64, which is 128 grams, and I have 1 sulfur, which weighs 64 grams. 64 plus 128 is 159 grams of Cu2S per mole. Okay, so I'll plug that in, and you can do the math problem. Grams and grams will cross off, moles and moles of copper will cross off, moles and moles of copper sulfide will cross off, and if you punch that into your calculator correctly, you'll get 13.3 grams of Cu2S. Okay, we're not done yet. We need to do this again for the other reaction, the other reagent that they gave us, the 3.8 grams of sulfur. So a first step is always to convert to moles. To do that, we'll divide by the molar mass of sulfur. You get that right off the periodic table. That's 32 grams per mole. Our second step is our mole-mole ratio step. It looks like we have 1 mole of sulfur for every 1 mole of our product. And then our last step is always the same, which is nice. We want to convert to grams of our product, and we've already figured that out, so we don't need to figure it out again. For every 1 mole of Cu2S, I have 159 grams of Cu2S. So let's do our crossing off. Grams of sulfur and grams of sulfur go away. Moles of sulfur and moles of sulfur cross off. Moles of Cu2S and moles of Cu2S cross off. And then we punch that into our calculator. 3.83 divided by 32 times 159 is 19 grams of Cu2S. We're still not done. We need to solve for the question, which is saying how many grams of the product will be formed. Are we going to make 13.3 grams or are we going to make 19 grams? We're always going to make whatever the least number is. So this is our limiting reagent. The copper is going to run out before the sulfur does. When the copper runs out, we're going to make 13.3 grams and the reaction is going to stop. That's analogous to us stopping when we get to our third sandwich. We can't make our fourth sandwich because we've run out of ham. Now we will never get to this 19 grams of our product because despite the fact we still have this sulfur sitting around waiting, we've run out of copper. It's like having the extra bread or the extra mustard, but the ham's gone. We'll never get to that fourth sandwich. We'll never get to 19 grams because we've run out of copper first. So this is showing what I'm kind of talking about graphically. So if I'm starting with 2 moles of copper and 1 mole of sulfur in the beginning, I have no moles of my product. But as the reaction progresses, what happens is I use up that copper and I'm using up that sulfur as I get to my 13 grams of copper 2 sulfide, copper 1 sulfide, sorry. But the copper is gone by the time I've gotten to my 13.3 grams. I have some sulfur left over, but I can't make any more of this because I'm out of the copper. Okay, here's another example. Go ahead and pause the video and try this in your notebook on your own. When you're ready, unpause it and I will walk you through the example problem. Okay, so we see that they've given us 2 numbers in the problem, 10.3 grams of aluminum and 51.7 grams of copper 2 sulfide. But what they haven't given us is a balanced chemical reaction. So you need to do that first before you do the 2 stoichiometry problems. So I'm reacting aluminum with copper. So I have aluminum plus copper. No, I'm reacting it with copper 2 sulfide. So copper 2 means it's a +2 charge, and it's sulfate. Sulfate is a polyatomic ion, that's SO4. On table E, that's a 2- charge. You should recognize this as a single replacement reaction. The aluminum is going to swap places with the copper. I'm going to have copper all by itself as one product, and my other product is going to be aluminum with its 3+ charge paired up with sulfate with its 2-. These charges don't balance, so I'll crisscross this 2 here and this 3 there. Don't forget your parentheses. Next, we need to balance the equation. This equation isn't correctly balanced. So I'll put a 2 over here to balance out my aluminums, and I'll put a 3 there to balance out my sulfates, and I'm going to need a 3 there to balance out the coppers. Okay, so now it's time to figure out who the limiting reagent is. So we need to do our 2 stoichiometry problems with our 2 numbers that they've given us. So we'll start with the aluminum first. 10.3 grams of aluminum. First step is always convert to moles. And 1 mole of aluminum, we have 27 grams of aluminum. Our second bracket is to use our mole-mole ratios to convert away from aluminum and into what they're asking us for, which is copper. How many grams of copper? So I want to get out of aluminum and into copper. So I have 2 moles of aluminum according to my balance equation for every 3 moles of copper. And my last bracket is to convert from moles of copper into grams of copper. Copper is right on the periodic table. It weighs 64. So let's cross off everything above and below. That cancels. That leaves me with grams of copper, which is what the question's asking. So now it's time to punch it into the calculator. 10.3 divided by 27 times 3 divided by 2 times 64 is 36.6 grams of copper. Not done yet. We need to do the exact same process with the other piece of information that they give us, the 51.7 grams of copper sulfate. Okay, so 1 mole of copper sulfate weighs 160 grams. You need to look up each element on the periodic table and record it in some kind of table, or you might be able to do this in your calculator, but you'll get 160 grams if you did it correctly. Then we do our mole-mole ratio, which is 3 to 3. For every 3 moles of copper, we have 3 moles of copper sulfate. And then our last step is to convert to grams of copper. 1 mole of copper still weighs 64 grams. We'll cross off everything the way we should, above and below. That cancels off. We're left with grams, so I know it's time to go to the calculator. And if you perform this math, you will get 20.7 grams of copper. So who is the limiting reagent here? Well, it is this one. CuSO4 is the limiting reagent because 20.7 is a lower number than 36.6 grams. So I'm going to stop this reaction at 20.7 grams of product because I'm going to run out of the copper sulfate. So the limiting reagent, remember, is the reagent that you run out of first in a chemical reaction. To find the limiting reagent, you need to do two mass-to-mass stoichiometric problems. Whichever reactant theoretically makes the least amount of product, that is your limiting reagent.